Hello again, class. In this video we're going to talk about graphing quadratic functions, and we're going to talk about some key features involved in quadratic functions and their graphs. So we'll start off with a parabola. The parabola is a name for the U-shaped graph formed when you graph a quadratic function. So just quickly sketching off a graph here, right? We have a U-shaped graph. This is typically what it looks like. That's known as a parabola. Some other key features here. The vertex is either the highest or the lowest point of a parabola, depending on what kind of graph you have. What I just sketched is a positive graph. Okay, so that's a positive graph, or a happy face graph. You'll notice that it looks like a smile. So that is a positive quadratic function, positive parabola. The vertex in this situation is going to be what's known as the minimum, or the lowest point. So we come down here to our bottom of the trough. That's going to be known as the vertex. The vertex is special because it breaks the graph into two symmetric pieces. On both sides of the vertex, the graph has identical y values. And that's really important for identifying the middle of the graph so that you can graph the rest of the equation. The roots of a quadratic function are the points where the graph crosses the x-axis, also known as the x-intercepts. To find the roots, all you have to do is plug in y equals 0. So just plug in y equals 0. And then you calculate to figure out the roots. The y-intercept, all you have to plug in is x equals 0 and solve your equation for that. Now the roots in this situation, there are two roots. So there are two places where the graph crosses the x-axis. And for the y-intercept, there is 1 point. There will always be one y-intercept when you're graphing quadratics. When you're graphing quadratic equations, the roots actually have three options. You could have two roots, as in this situation here. Get rid of this quickly. You could also have a situation where there is one root, where the graph just barely comes down and touches the x-axis. You could also have a situation where there are no roots. So you notice that the graph does not cross the x-axis. Okay, to find the vertex, we use a simple formula. The formula is x equals negative b over 2a. This formula finds the line of symmetry, the axis of symmetry that divides our graph into two pieces. All you have to do is plug in the corresponding values from your quadratic equation, and it calculates an x value. And we can do that pretty easily here. So our b value in this quadratic equation is negative 16. Our a value is 2. So the axis of symmetry, the middle x value for this graph, is going to be 16 divided by 4, which is 4. So that value of x equals 4 means that the middle of this graph is on the 4 value for x. It's somewhere along that x equals 4 line. So how does that help us? Well, now we can simply plug in 4 for our x values, and we can calculate the y value for our vertex. So it's as simple as plugging in and then doing the math. And if we do that math, 4 squared is 16, negative 16 times 4 is negative 64. And when we're all said and done, our y value for the situation is going to come out to be 1. So I can use that value to graph the vertex. The x value of 4, y value of 1, and that is the vertex of the graph. We know that this is a positive quadratic function, so it should be a U-shaped graph. So right there, if you're on a multiple choice test, you should be able to differentiate this graph from several other ones because you know that the lowest point in the graph is going to be at that point, and it should be an upward facing parabola. We don't know the specifics yet. We can find those using our other value, or using some more advanced techniques, but right now we can differentiate from several other graphs using that information. So we know that the middle of this graph is at 4, and now we can go in either direction to plot a couple more points to make sure that our graph is looking right. So we can plug in 5 in one direction, we can plug in 3 in the other direction, and I actually know, since this graph is symmetric, whatever I get for my y value for 3, my y value for 5 will be the same exact number. So you actually only have to calculate it once. So I know my output for 4, when I plug in 4 is 1, and now I can just go through and do the math, just do the calculations. And just to save us some time, if I plug in 3, you get out 3, so we can graph that here. And I know that my output value when I plug in 5 should be the same because my graph should be symmetric around that point. So we can sketch our graph now and get a little bit more accurate. And the next characteristic are the roots of a quadratic equation. So the roots are found by plugging in y equals 0. So if I simply just plug in 0 for y here and solve for x, we're going to have to use some skills that we just learned in the previous objectives, solving quadratic equations. So to solve this quadratic equation, I'm going to have to factor. All right, so now to find the roots, we have to factor this, break it down, solve for x. What multiplies to 24 and adds to negative 11? That's going to be negative 8 and negative 3 for this situation equals 0. Now, using the zero product property, we can say that either one of these chunks is equal to 0 because the whole thing is equal to 0. So I can say x minus 8 equals 0 or x minus 3 equals 0. So the roots of this function are going to be x equals 8 and x equals 3. So what that means for this situation, if I just do a quick sketch of the graph, that means at the x value of 8 and at the x value of 3, you're going to have 2 coordinate points. You also know that since this is a positive quadratic equation, it's going to be a happy face graph. So you can just quickly sketch the graph of this quadratic function using the roots in this situation. And finally, the last characteristic of a quadratic function is the y-intercept. And just like when we were dealing with lines, to find the y-intercept, we plug in x equals 0. So this one's a little bit easier. So 0 squared minus 11 times 0 plus 24. And you do the math, y ends up being, the y-intercept is equal to 24. So now you know where the quadratic equation crosses over the y-axis, and that's at 24 in this situation. So you might be saying, well, why is this information useful when all I have to do is do a t-chart? So yes, you can graph any equation using a t-chart. But if you used a t-chart in this situation, normally you start at 0 and you go in both directions a little ways. But if you plug those values into this situation, you're actually going to get a graph. These values are going to come out way, way, way high. They'll be off of your graph in the y direction here. We just found out that the roots are actually at 2 and over here at 8. So this graph is going to look something like this. So all of these values that you calculate out are going to be outrageously big. They're not going to fit on your graph. So to just quickly sketch the quadratic or the parabola for a quadratic equation, all you have to do is find the vertex and the roots, and typically you can just sketch the graph. Now, you won't always have 2 roots for every quadratic, but a lot of them you will. So always start off by finding the vertex. So we find the vertex by using the vertex formula, and we just simply say negative b over 2a. So we have x equals, my b value is negative 11, so we'll have negative 11 over 2a over 2 times my a value. So my axis of symmetry is going to be at 11 divided by 2, which is 5.5. So the middle of this graph is going to be somewhere along that line. And then you can plug that value in to find out where that exact value is. Now you can use this x value to pick some more points to plug in. So instead of plugging in 1 and 2 and 0, which aren't going to do you very much, you can actually plug in values that are closer to 5.5. So you can plug in 5, plug in 6, plug in 4, plug in 3, and those values will be closer to being on your graph. Okay, so just to recap, the parabola is the U-shaped graph of a quadratic equation or quadratic function. The vertex is found by using the formula x equals negative b over 2a. Once you have the axis of symmetry, you plug that value back into your equation to figure out your y value. To find the roots, you plug in y equals 0. To find the y-intercept, you plug in x equals 0 and solve your equations.